Unit 1, Day 2, Box and Whisker Plots. Objective: I will be able to compare, contrast, and analyze data, including data from real-world situations displayed in Box and Whisker Plots. Situation number 1. A study was conducted to determine the number of cars that passed through two intersections each day for 20 days. The results are summarized in these box and whisker plots. Which statement is best supported by these data? So we know best supported means most true or true. A. The range of the data for intersection 2 is twice. Remember, that means 2 times as much. The range of the data for intersection 1. B. The lower quartile for intersection 1 is greater than the lower quartile for intersection 2. C. The interquartile range for intersection 1 is the same as, we know that means equal, the interquartile range for intersection 2. D. The total number of vehicles that passed through intersection 2 is greater than, we know that means more than, symbol looks like that, the total number of vehicles that passed through intersection 1. So there are some words here that we know, but then there are some words like range and lower quartile and interquartile range that we may not recognize yet. So before we try to answer this question, let's take a look at some new vocabulary. Box and whisker plot. A box and whisker plot is a figure, that means a picture, used to map the spread of data or observations compared to the median. Spread means how far apart the observations are. It divides the data into equally sized portions. 25% of the data is represented by each quartile. Think quarter when you see quartile, and a quarter is like 25 cents when we're talking about money. So when you think of a quarter, you might think of 25 cents and how there are 4 of them in a dollar. Here is an example of a box and whisker plot. It shows us that the data goes from 20 all the way up to the value of 100, and that the median, which we remember is the middle of the data, is the middle point. See, you have 1, 2, 3, 4, 5 points represented. The middle point represents the median. So this value, this point right here, shows us that the median is 70 in this box and whisker plot. Then we know that half of the data is below 70 and half of the data is above 70, and each of these quartiles, these sections, contain an equal, which is same, amount of data, 25%. So in this section, from 20 up to 60, there is 25% of the data. From 60 to 70, there is 25% of the data. From 70 to 85, there is 25% of the data. And from 85 to 100 is 25% of the data. But why does this look longer if it's an equal amount of data than it is in this small section? Because the data is more spread apart. Other things besides the median that a box and whisker plot tells us is the lower extreme or the minimum. This is the smallest value in the data set. So we look at this point most to the left and we see that 20 is the lower extreme of this data set. The upper extreme, or the maximum, is the largest value in the data set. Looking at the point that's most to the right, we see that 100 is the upper extreme for this data set. Then we have the lower quartile, or Q1, and the upper quartile, or Q3, as you'll see it on the calculator. These quartiles are the middle of the data, either below the median or the middle of the data above the median. So when we look at this half of the data, the point in the middle is right here. This middle point of the lower half is at 60. So 60 is the lower quartile. And then we look at the upper half, and the middle is this point right here, which is between 80 and 90. That's 85. 85 is the upper quartile. The range of this data set is the difference between the max value and the min value. Remember, difference means subtract. How far apart are they? So remember, the max value, or the upper extreme, is 100. The lower extreme, or the min value, was 20. So we subtract 100 minus 20, and we see the range is 80. The interquartile range, or IQR for short, is the difference between the upper quartile, Q3, and the lower quartile, Q1. So it's like the range where we subtract, except we're subtracting the upper quartile, which we said was 85, and the lower quartile, which we showed as 60. 85 minus 60, or 25. Let's look at some more examples. A. If the above box and whisker plot is based on 200 data points, how many are in each quartile? How many? So remember, before we said that there are 25% in this quartile, in this section, and 25% in this section, and 25%, and 25%. So we know that it's split equally in each quartile, and that there are 4 of them. So if we know there are 200 data points, we will take 200, divide by 4, and we find that there are 50 data points in each quartile. So in the first quartile, there are 50. In the second quartile, 50, 50, and 50. So in this tiny little section, all the 50 data points are clumped together. Here, the data points are spread apart. B. How many data points are greater than 60? How many? So we're looking again for a number. Greater than 60. So I'm looking at, where is the 60? Right here. How many data points are greater than 60? Well, if there's 50, and then 50, and then 50, we're going to combine all of those, because over here this is less than. We want greater than, more than 60. So it's 50 plus 50 plus 50 for the 3 quartiles above that data point, and that makes 150. There are 150 data points greater than 60. Let's take a look at situation number 2. Data was collected on the weight of birds, plot A, and squirrels, plot B. So see, plot A is the birds, and plot B is the squirrels. Sometimes if our box and whisker plot is not labeled, it's good to do that first. 278 birds, so we know that altogether there are 278 of them, and 125 squirrels, so altogether there are 125 of them, were weighed in grams. compare box and whisker plots A and B to answer each question. Before we begin answering questions, remember that each part of the box and whisker plot is equally dividing all the data points. So if there are 278 birds, I'm going to take 278 and divide by 4 to find out how much is in each quartile. That equals 69.5. So I know that there are 69 data points in each of the 4 quartiles. There's maybe 1 or 2 data points that's sitting exactly on one of these middle or extreme points. 125 squirrels divided equally by 4 sections makes 31.25. So I know there are 31 data points in each of these 4 quartiles. Maybe 1 or 2 left over sitting on one of the middle points. A. Which plot has the lesser range? Lesser. So lesser, we can think of smaller, but I'm going to have to find the range of both of the plots. So for plot A, remember that the range is the upper extreme minus the lower extreme. So the upper extreme for plot A is at 100, and the lower extreme for plot A is at 50. 100 minus 50 is 50. Now for plot B, the upper extreme is again at 100, but the lower extreme is different. It's at 20. 100 minus 20 is 80. So which plot has the lesser range or the smaller range? 50 is smaller than 80. Therefore, plot A has the lesser range. Plot A is my answer because 50 is less than 80. B. Which plot has the greater interquartile range? Greater, so we think of more, interquartile range. So again, looking at both plots, plot A, the upper quartile is at 80. The lower quartile is at 65, and 80 minus 65 makes 25. For plot B, the upper quartile is at 85, and the lower quartile is at 60. And 85 minus 60 is 25. Oops, I just realized that this is not 25. Silly, that's 15. Of course, plot A has a smaller interquartile range because see how the box is shorter than this box? This box is long, this box is short. So even just looking at the picture, we can tell that the greater interquartile range is the one that's longer, and that would be plot B. So we can say plot B. If we need to give a reason, we can say because of the numbers. 25 is greater than 15. What percent of data in plot B is between 60 and 85? So remember, percent, there's 25% in each quartile. So in plot B, we have to look, that's the second one, between 60 and 85. So 60 and 85 is from this point to this point. That consists of 2 quartiles where 25% is in this one and 25% is in this one. So 25% plus 25% is 50% of the data that's between 60 and 85? D, how many birds are below the lower quartile? Below the lower quartile. So first remember how many birds are in each quartile because we divided by 4. Below the lower quartile, here's the lower quartile, below is that way. So that's this section right here where there are 69 birds. How many total animals are less than 70 grams of weight? So total is all of the birds and all of the squirrels put together. So 278 plus 125 is 403. And remember that 70 is the median for both plots. So below or less than 70 would be 50% or half of the data because half of the data is above 70. So the total animals divided by 2 is 201.5. So there are 201 total animals less than 70 in the lower half. There would be 201 in the upper half, and 1 would be on the median. F. Which category of animals, birds or squirrels, has the most animals that weigh less than 70 grams? So it may be deceiving that the box and whisker plot looks larger for the squirrels less than 70. However, according to the numbers, we see that there are more of them less than 70 for the birds' box and whisker plots. Here are calculator instructions for creating and using a box and whisker plot given a list. Take a moment to write a short summary. Why do you think a box and whisker plot is useful when analyzing data? See you in class.